Hello students, this is demonstration for the concept mutual exclusion and this is Nithyapriya. In this mutual exclusion we are going to see about mutual exclusion, then the requirements for mutual exclusion, for handling mutual exclusion, then we have a scenario for mutual exclusion, right? So what is mutual exclusion? Mutual exclusion is it is a process of handling a single resource. Okay, so the resource should not be handled by more than one processes at a time. Okay, so if a process is using a resource, the other process should not interfere for using the same resource, right? So when the waiting process can use the resource. If at all the current process releases the resource, then only the waiting process can access the resource. So this is called mutual exclusion. Working along with the resource without any interruption. Okay, so this is called mutual exclusion. Right. So mutual exclusion in single computer versus distributed system. In single computer is normally personal computer. So in personal computer, by mandatory, the resources like memory and I/O devices will be shared between different processes. So there won't be any need for this mutual exclusion. It is actually there in the personal computer, for example, single computer system, right? So the status of shared resources and the status of users, they are easily available in shared memory with the help of shared variable. Shared variable are semaphores, okay, shared variables, and mutual exclusion problem will be easily solved. So in single computer system there won't be mutual exclusion. Mutual exclusion is already there. Okay, we need not write any algorithm for single computer, right? The handling of mutual exclusion is needed only for distributed system. It is not needed in single computer system. It is needed only for distributed system. In distributed system, none of the resources will be shared. Okay, like single computer system. In distributed system, none of the resources will be shared. Okay, so no sharing of memory, no sharing of clock, no sharing of any I/O devices. But this is there in the case of case of distributed systems. So how can we solve distributed mutual exclusion problem in distributed system, right? So to handle mutual exclusion in distributed system, we have the following four requirements. They are no deadlock, no starvation, no fairness, fault tolerance. So no deadlock. What is a deadlock? Deadlock is when more than one processes grabbing a single resource, and as a result the resource will not be available for any of the process. Okay, so this is called deadlock, right? So this type of deadlock should not be there in the system to handle mutual exclusion. So next one is no starvation. No starvation is any process should not wait indefinitely to execute a resource. Here we mean critical section. Critical section is the area in which no other process can enter. Only the current process can be executed. So that's called critical section. So instead of saying critical section, I say resource, right? You understand it, right? So any process should not wait indefinitely for any resource. Okay, so at the same time the other sides should not use the critical section repeatedly. Okay, so there should be no starvation for any in the distributed system. No process should wait for resource without getting it, for a long time without getting it, right? So that is called starvation. Then fairness. Fairness is the order in which the processes enter, the same order the resources should be supplied. The firstly come process should be supplied the resource the first. The thirdly come process should be supplied the resource the third. Okay, and so on. If one process enters as the fifth process, if already 4 processes are waiting, the fifth process, when it gets the resource without the before the 4 processes, it won't be fair. It will be unfair, right? So this unfair supply of resources should not happen in distributed system. This is the third requirement. The fourth one is fault tolerance. Fault tolerance is, if any disturbance happens, if any failure happens, the process should be able to recognize it by itself, and it should not be disturbed in execution. It should not be disturbed in any point of time for its execution. So this is called fault tolerance. Fault tolerance. If any disturbance is there, even if an interruption comes, even if a failure is there, the system should function properly. So this is called fault tolerance. And these are the 4 requirements: no deadlock, no starvation, fairness should be there, fault tolerance should be there. Okay, so if those requirements are there in a distributed system, then we can handle mutual exclusion. And this is an example scenario for you for demonstrating the mutual exclusion. See, there are 3 processes and there are 3 resources. Firstly, P1 was using resource 1 and now it is releasing resource 1 to P2. Actually, P2 was using R2, resource 2. Now it is releasing that R2 to P3. Okay. Now P3 was already having R3, that is resource 3, and that resource 3 would be released by P3, which will be used by P1. So no resource will be taken by single process, and no process is waiting with starvation. Okay. So this is scenario. By this scenario, I hope you would have better understood the process of mutual exclusion. And that's all for now. Thank you.